So, welcome back to the shop for the second installment in the series. This time we're back here with the Ampeg. It's been a while. Took me a while to get the fuses ordered and everything, but here we are. So yeah, I have a new fuse in it, 6.3. Apparently, according to the specifications, this should actually take a 20 by 5mm fuse or 5 by 20mm fuse, even though the holder seems to be for like inch-long fuses. But I can't find any according to those specs, so yeah, let's try it. So yeah, we should start with turning on the isolation transformer. As we're going to set those to 0 watts. For starters, turn on the transformer, and we're going to give it just 40 watts to start with. And if we look here, whoa, there we can see the cup's charging up and it's trying to start, but it doesn't really look like a short to me. We're pulling almost no current, so let's just give it a second light bulb. And would you look at that? There we go. It starts up and it's drawing. It's a bit high, but I think we'll go ahead and give it another 60 watts. And now, as you can see, the bulbs are almost out. But we'll drop it down to 100 watts. And it seems to be quite alright. The blue LEDs come on over there. My camera might pick it up, but it illuminates a purple bar below the Ampeg logo. And yeah, this looks promising. So yeah, let me set up a test speaker and we'll see what's what. So yeah, let's plug in a test speaker. Yeah, that's the speaker output. And yeah, I have a small 20 watt orange, one of these 8-inch, I think. It's rather nifty, cheapest I could find, but it's nice to have an actual orange product than just test speaker, but hey, it was cheap. So yeah, let's turn down the master volume and the gain, and yeah, let's give it a little thick, and there's another one. Okay, so the master doesn't do much. Let me give it some gain. I can't really hear anything. That's actually might be a good sign. So yeah, what do you think? Should we give it a test signal? I have it actually set up over here. This is the cable from my signal generator, so we're going to plug that into the input. Now we need to be a bit careful here because I'm not quite sure if my signal generator is a reference to ground. Let's check that, shall we? Yeah, let's check that. So, welcome back. Now, let me try this. We'll put on the HP. Yeah, I know. For a guy that barely knows what he's doing, then this might be a bit overkill. But as you see, we have it in continuity mode. We're going to beep our probes together. Now I know that oscilloscope, which you might even see, is conducts to ground, and I know that my isolation transformer, slightly out of shot, is also referenced to ground. The chassis of my isolation transformer, I might add. So now if we beep that to our, yeah, you can see that both the output of my signal generator is ground referenced. This is a bit of a bad thing, or something you need to be cognizant of, because, oh well, let me reposition. So yeah, welcome back again. So now, since we do know that our signal generator is referenced to ground, now let's rerun that test just to demonstrate my point here. We have the signal generators plugged in right here. As again, I will put my scope probe on this case of the isolation transformer that is grounded. Ah! Would you look at that? No, my point was that since my signal generator is referenced to ground, the black lead of the sheath thing of the cable, then there's a big chance to introduce a ground reference to the circuit, which would then render your isolation transformer pointless, basically, because suddenly you are giving it a ground reference, and if you ground the case through your signal generator inadvertently, then you will also reference the 230 volt AC side to that, which means that you are now, the whole point of the isolation transformer is that when you touch something, you provide the ground reference, which then basically keeps you safe. But in this case, they have actually isolated, so the signal ground isn't the same thing as the chassis ground, which is fortunate. Means the isolation transformer should keep us safe still. But anyhow, let's not take any chances and be a bit careful. But yeah, as you saw in the last shot, insert here, the signal generator is set to 1 kilohertz sine wave at 100 millivolts peak to peak. And yeah, so let's turn on the amp. As soon as I can find the power switch back there. And as you can see, the fault light briefly illuminates. That seems to be normal operation, probably since we are current limited, so it takes a while for the caps to charge. Now you can see the fan came on and the little light came on. So we'll gauge the output, give it, can you hear? And the gain does work. It's very subtle, while the master volume is very responsive. All these pots are really, like, they're not stiff, they're like dampened almost. There's like, you have to be quite purposeful with them. But yeah, seems to work. Let's see if the pad does anything. Yeah, that knocks 15 dB of the signal, I presume. And we have to be a bit careful with this, because this one is capable of pushing 250 watts at 8 ohms impedance, speaker impedance. And that speaker that I have over there can only handle 20 watts. So, but you know, for test setups, that's okay. We just don't need to push a very lot of signal through it. So, this leaves me with a bit of a conundrum. There was supposedly some sort of issue. Let me turn that off so we don't have to listen to it. There was supposedly some sort of issue with this. I can't remember what the eBay listing said, but there was something about some, you know, ground rumble or whatever. And when we got it, we had that blown fuse. So I'm not quite sure what to think about this, because now the only thing I did was pop in a fuse, and we turned this 40-pound piece of junk into a, I guess, 300 euro-ish amplifier. These are 350 euros new. So that's a bit concerning. And what did cause a 6 amp fuse to blow? That's like 6 amps, that's several kilowatts. That's 1.2 kilowatts, something like that. Yeah, 6 times. It's more actually. Yeah, so the only thing that I could think of that theoretically could pop a fuse that quickly would be if they had the power selector or the voltage selector, which this one does have, set to 150 volts, 115 volts. It's also a bit weird because I can't see how you can reconfigure a transformer. But this one is switched. It doesn't have a linear. This has to be a switching transformer or a switching power supply, this one. So that's how they get away with just, connecting or disconnecting a single path, I guess. Well, anyhow, regard, I found it a bit weird. I'm not going to bother looking up how they actually do that. But so what I'm thinking is that's either thing, because that would pull extreme amounts of current, but then it's a switcher, so don't really know. The other option is that one of these caps are bad. We don't hear any like 50 cycle hum or anything like that, which would indicate that it's probably not an issue. But then again, I don't know. I've read some, looked online, and these caps are prone to failure. This one is a bit bulged. This one is very slight. You can't really see it, but you can feel it. And these high voltage 100 volt caps. So while we have it on the bench, it's easy enough to yank all the screws. There's like 8 holding it in. Take out the caps and refit those just to give it, a bit on the safe side, since I don't have a lot of money into it. And this is actually something I might like to keep, because I have 2 Ampeg speakers, 15 or 2x10. It goes rather nicely with this one. But and this is like a nice simple amplifier. It has input, padding, 15 dB pad if you have a really hot signal going in, gain, bass, mid-range, treble, volume, master volume control. It has a limiter, which apparently does something, and then you have audio in, headphones out, which actually could have been used to test it, but So this is a nice light amplifier, and I actually have a Tech 21, one of these, DI stomp box things. I would go rather nicely with this one. It's and you should be able to, I guess, do a bit of overdrive with this one as well. So yeah, it's nice. I might like to keep it. So I think I'm going to refresh all the caps, or at least the big high voltage ones that are prone to failure, and see. These are 200 volt 1000 microfarad caps. These are 100 volt 820 microfarad caps. So there's quite a bit of filtering and large bulk capacitors in this, which is also something you need to be careful of whenever you're working one of these. It's not insane high voltage, you probably wouldn't die from it, but 200 volts discharging out of something that's basically 1 millifarad, that would at least hurt, if not kill you. So yeah, but I'll get those caps ordered, and next time you see it, I'll probably have pulled the board, and we can then desolder these and get them out of there, and see if I could find some of this Celestic, is it maybe called? Yeah, and yeah, we'll see. But yeah, really pleased. That's the only thing that's wrong with it was a fuse, allegedly. But this doesn't really make sense. I have to dig up that eBay listing and see if I can, put it on screen or maybe tell you about it next time. Yeah, so that's rather cool. Yeah, so. Thank you for watching, and we'll see you soon. Bye-bye.